All right, here we go. My name is Alexandra Yates. I work for the Open Source Technology Center at Intel Corporation. I've been with Intel for about 6 years. And in my time off, I do triathlons. And for work, I do power management on the Linux kernel. Oh, and I forgot to introduce my talk. So we're going to talk about a case study. And basically, the way that this came about is I thought, well, how is the Linux kernel doing in terms of power management and in relationship of the different distributions that are out there? So I took first Ubuntu. I'm working with Debian. And the idea is that I go from distribution to distribution doing a similar thing that you're going to see today. So before we begin, I would like to see how many people here use any sort of power management tool to tune your computer. Very good. Very nice. All right. How many of you use PowerTOP? Woo! Great. Awesome. Good. I went to a talk the other day, and there were like 3 people. So this is good. Right, so the experiment, of course, I use Debian 3.14. Debian has its own kernel. So in this case, I use 3.14.13.2, which it came with the distribution for Jessie, is the code name that you give it. And then I took the upstream kernel and then slapped it on the system, and this is the latest is 3.16.1. I also made the same experiments as I mentioned earlier with Ubuntu 3.10, which they come with their own distribution, but I'm not going to come here and tell you all the things about Ubuntu. I'm just going to talk to you about Ubuntu 3.16.1 in this talk, and then of course everything else on Debian in those 2 kernels that you see up there. For the experiments, I use a really cool machine. This is a Sony Vaio Pro 3. It is 13 inches wide, and the best part about this computer is it's super light, and its battery power lasts about 6 hours and 30 minutes, they claim. But I've made it last a little longer, so if you like to take a look and pass it around. I love it. I really, really like that computer. It has touch screen. It has a really nice mouse track buttons, and it seems pretty responsive. And in terms of power, it seems to do very well. It has a Haswell ULT, Core i5 4200U, and it has 128 gigabytes SSD drive. Pretty cool computer if you're looking for a system to purchase. And also, this one is the computer of choice of Linus Torvalds. So yet another reason why I wanted to see how did it do in terms of power. Additionally to that, I use Yokogawa WT310. This is a power meter, and I also use a photometer to gauge the brightness of the screen. I use PowerTOP, and all my tests are 10 minutes intervals. I'm measuring wall power, suspend power management, idle power, and of course, I have to make sure that my battery is fully charged. I did the mistake that at the beginning I was taking this test and the battery wasn't charged and my numbers were going to the 20 watts range, and of course I was freaking out. So about the results. Well, no animals were harmed in this experiment. I have to give kudos to Debian because they did a really good job. It seems that they are pretty proactive at keeping PowerTOP updated every time there is a release. I've noticed with the other distributions I've installed, they usually have a very old version of PowerTOP. So kudos to them for that. So we're going to talk about, in the graphs that I'm going to show you, we're going to have on the x-axis watts, and then we are going to have times, and of course it's 10 minutes as mentioned before. And so before we go into depth into what this graph means, I took two tests, very simple tests. One is a screen on, idle, and the other one is a screen off, idle. And the reason why I took those tests to begin with is because if you think about it, probably 80% or 60% of the time your computer is idle, sitting there doing nothing, and most of the times you are like on your desk talking on the phone or something, and the computer is going to go to sleep, and you even go and touch the touch screen so that it doesn't actually go to sleep, and I sometimes do that. So that's what I thought this the most part where the computer lays. Right, so here in this graph, I took about out of the box Debian on that computer I'm showing you. I just installed the Jesse distribution and the up and the lower blue line is the screen of idle. And so what I did in here is I only changed the brightness of the computer. So if you look into all these computers that come out of the shop of the store, they come with a very bright screen, and they do it so that it looks very on the screen, and all that is great and nice. But it turns out that when you are working, you actually don't need all that brightness, and it's actually not that good for your eyes either. So the people from the panel guru, they say that it's actually good to have your screen in 200 nits, and 200 nits is just like an 200 lumens, and this is number where you can see the screen and you can work, and it looks bright, and it's very, very nice and comfortable for you to just do your work. So that's what I did with the photometer. I went and looked what was the 200 lumens there, and it turns out that in order to change my lumens, I need to go and change my nits on my system, and I do that by changing sys-class backlight. And sometimes, if, like in instance in this computer, we have Intel GPU, so we have Intel back and brightness. But there are some don't use that, and so then you are going to have a CPI taking that for you, or the driver that comes with. And then, of course, brightness. And so in here, I put it into 36. But the one thing that I want you to take away from here is that don't go to your computer and slap in 36 in there, because it's not going to work. Big chances is that. Just look what is the current number that you have. And usually I just half it, put it in half, and then add that number. If it is bright or if it's too dark, well, then just adjust it as you feel it works for you. But the thing in here is the idea to take away out of this slide is by only doing this, I am saving about 54 minutes of power by only just keeping my screen a little darker on the 6 hours that I have of battery. So that's a pretty good savings if you think about it in the long run. So in case the previous slide didn't put your imagination on how much power your panel takes, I put together this slide, and this is basically a pie chart that is showing me in the system how much my panel consumes. And as you can see here is 81%. The second citizen that uses more power is the CPU. And one can argue that one can tune the CPU to make it use less power, but effective, our panels are the big consumers. So just keep that present when you use your systems and you tune them for power. So the next step I did is I took the system and I installed Linux kernel 3.16.1. And again, I did the two tests, screen on and screen off, both idle, screen on idle and screen off idle for 10 minutes. And in here I found that my screen on idle and, and then after that I run PowerTOP. And then after running PowerTOP, I figured out that I saved with the screen on idle 1 hour and 45 minutes. And then I also save 3 hours on a screen off idle. So that is a lot of battery time. And if you are like in an airplane, many of you did that to come here to this conference, or traveling, or in your house, or somebody's friend's house without your battery charger, 3 hours is going to give you a lot of time to work, right? So keep that in mind. And this is also with the change of the backlight. So in here I'm kind of stepping stones on the changes that I'm adding. I'm not only run PowerTOP, but I added my Linux kernel. I changed my backlight to make it less bright, and then also run PowerTOP. So that was, I thought that was pretty neat that I saved 1 hour and 45 minutes. And then the screen off idle 3 hours. That's about 48% of difference here in power consumption. That's very good. Now the next slide, I am comparing my out-of-the-box versus the kernel. So the previous slide was that computer with kernel 3.16, but just by running PowerTOP. This one is the kernel that Debian had versus 3.16 kernel and doing exactly the same things. So in here, I found out that my screen on, I'm saving 2 hours and 24 minutes. And in a screen off idle, I save the same amount of time. And that's actually expected. But it is expected because the new releases of the kernels should have more patches. And since Haswell is still a new platform, there are patches that keep on going upstream for that. So that was nice. So a lot of you use PowerTOP, and in the different forums I found, and even in the mailing list, I hear people that they don't know what these numbers mean and how to use it and how to analyze this data. But so we're going to go a little bit about that data that you see on PowerTOP, and also I'm going to tell you how this computer did with the out-of-the-box kernel and with the screen off. So which in this screen we have process idle state report, and basically here is showing me what is my processor doing when it's supposed to be doing nothing, right? The processor is partitioned in different models, if you will, and it has this particular processor has 4 CPUs. There are grouped, CPUs are grouped by 2s in this processor, and they are grouped in cores, and of course there are 2 cores, and then they are all grouped in a package. And in the CPUs in the core, they share memory and interconnects and things, and then in the package they share the buses, and you probably know all these things better than I. Anyway, so here the main idea that I want to show you is that in the screen off idle, when it's not tuned, my CPUs are reaching 98% on the deep C states. And if you're familiar with power management features of Haswell ULT, they added different C states. And a C state is basically a place, I call it a place, that the software goes and turns off certain things of the system. So for instance, C0 is when the system is all fully up. All the power is going through all the systems. C3 to 6, the system is turning off certain buses, and the C6 is turning off the memory caches in certain parts of the memory. And then it keeps on going down until the memory is totally flush and turned off all the way to C10, and also the buses and the lines, and it just goes down, turning off to minimize the amount of power that they use, all the way to C10. So the other thing I noticed here is that in my course, I'm reaching C7 residency, and that is good. And on my GPU, I'm also reaching RC6 residency, which is good. But if you notice, on my package level, all my numbers are on C2 residency. And that is a problem, because that means that the package is just not turning completely down to the idle state that is supposed to go. And if I go and look into the tune after I run PowerTOP and did all these things that turn down the screen, color, and all these things that I just explained, I'm still in the same position where I only have my package level 99.1% in C2 residency, and the rest of my deep C states don't have any percentage. So that's a problem. And so I went and asked people around, and why would that be? And it turns out that the graphics driver, usually in these cases, the bigger issues lay either on the graphics driver, on the sound drivers, and the third resident is the networking. So usually those three groups are the ones that have the most problems in terms of power management. So I went and asked, and it turns out that the Intel driver has panel self-refresh setting flag that I can set when I start my kernel, and I had to set that. And also there were a couple of other flags that I'm pointing right here. The PCIe ISPM4s, and in this, once I set that, I should go, when I do my screen off, I was able to go and do C7 residency, which is good. Before it was tuned. And then when I went when I went and tuned my machine, I should have gotten C10 residency, and I didn't update this part, but the point in here is that I didn't get my C10 residency as I was supposed to get it. So focus on the left-hand side, and it should C10 or some sort of residency in there after it's tuned, after you run PowerTOP, after you turn down your things, and you have this flag set on your kernel to start up your system. So that's a problem, because this was with kernel 3.16.0. And so I went back and asked the people, what's going on here? We are having a regression. Sure enough, we did have a regression. And the patch was already uploaded into our internal app to be upstream in the next version of 3.16.0. And there is also another regression that I'm working on and just debugging at the moment. That it has to do with panel self-refresh. And it turns out that with the panel self-refresh, I noticed in this computer, I get a lot of flicker in the screen with kernel 3.16.0, and it's awful because you can definitely, it's just not usable, the computer, unless you are on like a lower screen level. So they are working out those patches. And when I did this test, we've seen previous kernels and also Ubuntu. I didn't run in many issues. I actually was able to reach my C10 residency by doing these things that I'm explaining here. So that's something to take. And those are some easy steps that one can do, and they just don't take much time. So another thing that if it's not the kernel and if you are not sure what's going on, then it might be that the software that you have loaded on your computer is just not behaving properly. A place to go and look into that is PowerTOP, of course. And you can look into the amount of Wakeups that the system has. PowerTOP gives you a really nice list of the software processes that are taking the most amount of Wakeups. And if you take a look in here, of course, the Intel graphics driver is listed in there. So that would be a way to point out if you are debugging this kind of problems. But if you are also debugging your driver, you can come and test your driver with this, and it should tell you if you're being delinquent on the Wakeups per second. This is a nice chart, and it's meant to be like that. Another setting that PowerTOP has is the ability to tell you what are the device drivers and the devices that are not tuned correctly for power management. And so if you go to the last tab of PowerTOP, it's called Tunables. And in what PowerTOP shows you here in the HTML form is it gives you the script that you should run on your computer so that you can tune that device for power in terms of power management. And so once you go and test that every one of them work, you could only just run PowerTOP Auto Tune every time you start your computer. PowerTOP doesn't keep a memory every time you restart your computer of these things, because we don't consider this is our job. PowerTOP as a tool is a tool more to help you identify and get better usage of your computer, but we feel that will be more work of the distribution actually than us. I feel distributions will be should be more hands-on on getting these systems to tune their software on the systems, or at least on the more common systems that are out there. So if you have your Linux system and you are tired of tuning it every time, just go ahead and put this into your startup script, and that should do it for you after you test every one of them, because at times that might break your system. So be aware of that. Yeah, because and it's not because PowerTOP, but it's because there are these devices out there that don't have really good drivers, and when you go and tune it in terms of power, it turns out that the device doesn't behave well, so it ends up breaking your system. So be careful. Well, now I did a study on what other devices, how the devices that I plug into this computer behave, like the mouse, SD drive, the USB card. I also took one of those memory cards and I slapped it in there and left it. You know, that's the scenario that we usually have as users. We just go upload our pictures and then we forget about our card that is still in there, and we just take it everywhere with us until it's the next time to go take pictures and we take it out again. So in terms of power management, how those things affect our system. And I think the mouse one is the most common, and I found it pretty cool. Sorry, but first we're going to talk about the background color. So, of course, the screen is very important, and as we already saw before, it takes a lot of power, right? So in this specific experiment, I was curious about how is the out-of-stock Debian gradient screen, which is pictured above in the screen, how does it behave with respect with a solid color And I was thinking, well, maybe I could test all different colors, right, if I'm very ambitious, but there is only limited time I have. So I picked white and black backgrounds to test. And I wanted to do also RGB, but again, my time was of an essence. So in here, I have my out-of-the-box Debian, and I compare that against my Debian when it was tuned, and that would be the light blue line is for the out-of-the-box Debian, and the dark blue line is for the Debian after it's tuned. And you can see the big difference in terms of how many watts you're saving here. You're saving about 4 watts only by just tuning your computer. And that was about, 4 minutes. It saves you, there is something wrong here. Anyways, then I went and compared my out-of-the-box Debian with my black background, and it saves you about 4 hours and 30 minutes of battery if you have a single black or white background. I actually went and tested both, and they both approximate to 4.5 hours of battery savings if you just go into from a gradient color to a one color background. And the reason for this is because the reason of this is because the frame buffer compression. And of course, the GPU needs to work a little hard to get these colors and these colors of the gradient process. And if you have only one color, well, it's much easier for the GPU, the memory, and all these things to get only the one color presented throughout the whole screen. So that was actually pretty interesting, that by changing my background brightness and also my background color to a solid color, I'm saving 4 hours and 30 minutes. I think that's a big win. The other thing was the mouse. So I put in my mouse, and I think the mouse is the most common case because a lot of people use in their computers those little pluggable mouses. I use a regular mouse that just has a whole tail and you're plugged forever, but it's very similar, the case. And basically, I have my screen on and my screen off idle. And my screen on is like a reference of how it behaves. And then I have my mouse out of the box, which is the blue line, which is very similar to my screen on. It is good and comparable, so that means that your mouse is not really eating your battery. There are some mice out there that are criminals on this, so be aware of that. And then I did my mouse on the 316, and you notice it's still good. But then I did tune the system by having the mouse connected, and the difference was so great. It is about 2 hours and 25 minutes of battery savings by having my mouse tuned. So if I can have my mouse, the convenience of using my mouse, especially now with this tracking thingies, I forgot the name of it, the panels, the track panels that are so complicated to use, especially if you are not used to it and you have the convenience of having your mouse. You will have 2 more hours only if you just tune your system. That is big savings and very nice and convenient. So highly recommend to tune your system when you just anytime. Now we're going to talk about other distributions. And again, I only have Ubuntu and Debian at the moment to compare. I will have all the distributions through the time. This has been about 6 months of work on doing these presentations, and the more I do, I learned that I have to, of course, go to the next new kernel and retake all my data in both distributions, and then also just update things and change, and it's been fun, but it's a lot of time. Anyways, in here, it was actually very nice and comparable. I was pleasantly surprised, but the one thing I thought was actually weird is that Ubuntu behaved a little bit better than Debian within the screen on idle. And the one thing I did in this test to make it more like a common base, I used kernel 3.16. And I also use PowerTOP. I make sure that my system was fully tuned in order to make this happen. And the reason why I did this is because usually with the distributions that come, the kernels that come within the distributions, they have certain changes that are specific for that distribution, and they just have so many tweaks and things. And so I think it would be more fair to compare apples to apples here. So for the screen on idle, if you use Ubuntu, you will have 19 more minutes of battery life. And with the screen of idle, you have 11 more minutes. It's small, but I feel there is room for improvement in there, in the Debian world. And then chances are that in the next kernel release, things change. I'm not sure what would be the variables here, but in order to identify what makes this difference, I feel one will have to go in a deep understanding on what are the different components of the system and how they are behaving in terms of power, of course. Okay, so as you know, there is a lot of room for improvement here. Again, kudos to Debian to have PowerTOP, to have the latest version of it installed. But I still feel that the distributions can do a more aggressive approach to do better power management on the systems that are out there. Ubuntu, for instance, they are trying to be good class citizens, and they have a place where they say these are the platforms that we badge for. And they even have a website, and they have a list in there of the systems. It's very cool, but I feel they could do a little more. and we all could do a little more, right? And what I mean by that is, like for instance, I show you there were some changes on the graphics driver, Intel graphics driver, and that if you use those flags, your system will behave better and will have a better, it will have more mileage. Your battery will have more mileage, right? The question in here is, how do you know that you have to actually set those flags, right? Well, that is something that we are working at Intel and trying to get that data out there for the community to learn. But I feel that we could work in a better partnership with our distribution partners and solidify that methodology where this data gets to their hands. That's one place that I see that we can influence and get better at. And I feel this forum is a great opportunity to open that discussion. The second thing I feel that we could do better is the distributions probably could have a database when they install the system where they know what are the best known configurations and match that to that configuration and do that for the user so that the user doesn't have to run PowerTOP every time that they start the computer. That would be very nice. But that will take a lot of work, I understand, on the part of the distributions. There is always a happy medium, right? So the happy medium in my scenario here is, how about giving the ability to the user of tuning their power when they install the distribution on their computer? Having the ability to survey what are the devices, probably using even PowerTOP or a subsection of PowerTOP, or the tool that you have that you like, and run it while you do your installation so that those configurations are kept throughout the life of the computer. I feel that would be a very good thing if it happened from the distributions. And then the other thing is, well, this is actually a boring one, but I'm going to be boring and use solid colors for your backgrounds, because that's what it is up most of the times on the computer. And yes, it's boring, but it saves, you guys save a lot of power. And then I think that's all the things I feel that we could do that I can think of at the moment. I want also to invite, before I go to that, I want to invite everybody who is in this room to be part of PowerTOP. As you are all users, or most of you are users, it happens that I am also the maintainer of PowerTOP. Hint, all the presentation, right? And it's a really nice community, and it's growing. And we accept patches from everybody. It's an open source project. And it would be really nice if we get more people engaged. So I would like to invite you all to go to one.org/PowerTOP and get our repos and start contributing and have ideas and bring them on. And then with that, I want to thank you and open the questions.
So just two quick questions. The first is, so how much in aggregate were you able to increase your battery life on?
So this was a system that lasts 6 hours and 30 minutes. And I put it, so it was lasting about 4 hours at first. And then I was lasting the 5, and then the full 6.5, and sometimes a little more, sometimes a little less. It changes, right? If I go back in terms of time, my last slide, one of the last slides tell us, the one with the screen, this one, that's the most amount of time that you will get. This is I did everything in here. I had my one color on the background. I tuned my system using PowerTOP. And I also added all the flags on my kernel startup, and so that did the trick for gaining 4 hours and 35 minutes altogether.
Cool. And the other question was, so how does this compare to other operating systems, which we shall name?
That's a good question. So actually, Windows is doing a really good job at tuning their operating systems to the new platforms. They are very aggressive, and they work with Intel into getting their systems. But it turns out that at the Open Source Technology Center, we only do Linux, right? So it's been, the visibility has been increasing, and there are more teams and more people and more engagement on that sense. There are a lot of platforms, of course, and there is Android, and then there are all the different distributions. But the idea is that with these presentations I'm giving, I spied more interest in the community, so that the different distributions open and help and do more work on terms of power management. Sure.
I'm sure I could look this up when I get home, but is PowerTOP an Intel-specific tool, or does it work with other processor families?
That's a very good question. So PowerTOP works mostly on Intel platforms. I know it has ports into some ARM architecture, and also AMD. Unfortunately, I don't have any of these things, and I don't do tests on them. We have a validation team which do, but it's very narrow, their scope in that terms. But yes, they have support. And again, it's an open source project. So if you see that you have a nice processor that you want to have the ability for that, be my guest, bring it on, and we receive your patches and we make it happen. Yes, right here.
Just to provide a bit more detail on the ARM stuff, it's slightly more. Intel are quite organised about having all those power states, and it's nice and consistent across the entire chip families. And AMD have done the same kind of thing. Whereas in ARM world, there's all sorts of power states, but they're completely different on every chip family. So it's a lot harder to go, what do we even call these states? So we haven't got the same consistency, which makes it rather harder to kind of provide the same feedback. But still, there is reasonable support for at least some chipsets. I'm not exactly sure what is and isn't. And they've realised this is a problem, and people are at least standardising some kind of level names. I haven't been keeping up with exactly what's been going on. But basically, Linaro has been doing quite a lot of this for the last 4 years. So you get more or less the same experience.
Thank you. I think we are out of time. They showed me the red card already. So if you have more questions, I will be at the hall or in the next sessions. And thank you very much. And don't forget to tune your systems in terms of power.